In 5.1, we saw that alkanes are hydrocarbons that contain only carbon-carbon single bonds. Alkenes are hydrocarbons with one or more carbon-carbon double bonds. They are called unsaturated hydrocarbons because they have fewer than the maximum number of hydrogens. Mathematically, this can be indicated by the following general formulas: CnH2n, where the number of carbon must be equal or greater than 2. In an alkene, the double bond contains one sigma bond and one pi bond. Early chemists found that an oily substance was formed when ethene, CH2CH2, the smallest alkene, reacted with chlorine. From this observation, alkenes were originally called olefins, which means oil forming. We have seen that the IUPAC system uses a suffix to denote certain functional groups. The carbon-carbon double bond is the functional group of an alkene, denoted by the suffix "-ine". There are several steps we must follow to name the alkenes. Step 1. Find the parent name. To determine the parent name, find the longest carbon chain that contains both carbon atoms of the double bond. For example, 2-carbon alkene is called an ethene, while 3-carbon alkene is called propene. Most alkenes names need a number to indicate the position of the double bond except for the ethene and propene because there is no ambiguity. The position of double bond is the same from left or right. Step 2. Number the main chain by give the double bond the lowest possible number. For example, for this molecule, if we number the carbon from left to right, the position of the carbon-carbon double bond is between carbon number 3 and carbon number 4. But if we number it from right to left, the position of carbon-carbon double bond between carbon number 1 and carbon number 2. So the longest continuous chain containing the carbon-carbon double bond is numbered in a direction that gives the suffix "-ine" the lowest possible number. For example, 1-butene signifies that the double bond is between the first and second carbon of butene. For the second molecule, 2-pentene signifies that the double bond is between the second and third carbons of pentene. If the position of double bond is at the same distance from the two ends, the lowest number is placed at the end near to the first branch point. For example, 1, 2, 3, 4, 5, 6. So the carbon-carbon double bond is between carbon number 3 and carbon number 4, but the first branch is at carbon number 2. Step 3. Write the name as a single word. The longest continuous chain, which is the parent name, is named using the first number assigned to the double bond. The name of a substituent is cited before the parent name together with a number to designate the carbon to which the substituent is attached. For the first example, the substituent is methyl, located at the second carbon, so the substituent is become 2-methyl. The longest continuous chain is 6-carbon and the double bond is placed between the third and fourth carbon, so the parent name is 3-hexene. As a single word, 2-methyl 3-hexene. If the compound has more than one substituent, the substituents are cited in alphabetically order. Have a look at the second example. We have 5-bromo and 4-chloro as substituents. The longest chain of carbon is 7 and the double bond is placed between carbon number 1 and carbon number 2. So the parent name is 1-heptene. As a single word, the IUPAC name for this compound is 5-bromo 4-chloro 1-heptene. As you can see, 5-bromo is cited first, followed by 4-chloro. For a compound with 2 double bonds, the suffix will become diene. For this compound, the double bond is placed between carbon number 1 and carbon number 2, also carbon number 3 and carbon number 4. The longest chain of carbon is 4-carbon, so the IUPAC name for this compound is 1,3-butadiene. For this compound, The double bond is placed between carbon number 1 and carbon number 2, also carbon number 4 and carbon number 5. The longest chain of carbon is 5, so the IUPAC name is 1,4-pentadiene. For cycloalkenes, a number is not needed to denote the position of the double bond because the ring is always numbered so that the double bond is between carbons 1 and 2. To assign number to any substituent, count around the ring in the direction clockwise or anti-clockwise that puts the lowest numbers into the name. For example, we have 1-methyl as a substituent, so we are going to put the numbers clockwise into the ring so that the position of double bond is between carbon number 1 and carbon number 2. So our substituent, the lowest number is 1-methyl. The parent is cyclohexene. As a single word, 1-methyl cyclohexene. Let's have a look at the second example. Number the ring. Now, our substituent is on carbon number 1 and carbon number 5. So, 1,5-dimethyl. We have 5 carbon as the longest chain. Cyclopentene. As a single word, 1,5-dimethyl cyclopentene. This 1,5-dimethyl cyclopentene is not called 2,3-dimethyl cyclopentene because 1,5-dimethyl cyclopentene has the lowest substituent number, which is 1. So 1 is smaller than 2.